So in this video we'll look at some trigonometric identities and have a look at some of the questions that can be asked in exams. There's four types of trigonometric identities. There's the compound angle formula. Take down an example of each. So take these down and it'll just give you more of a sense of what they are. There's the cos A minus B and A plus B formula. Let's use the A minus B. Cos A minus B is cos A cos B. Not Bill Cosby, just cos B minus sin A sin B. Now there's cos A plus B as well. May as well write them all down. Cos A plus B is also cos A, Bill cos B, and then plus sin A sin B. So if you remember one, you don't have to remember any of these. They're obviously in the formula booklet, but no harm to be aware of them. I wouldn't try and learn them off because they're all so close that you could easily write the wrong thing down. So sin A plus B is sin A cos B plus cos A sin B. That's a plus in the middle. Sin A minus B is sin A cos B. Would you have a guess at the rest of it? Sin A cos B. What would you say the rest of it is? Minus cos A sin B. We also have tan A plus B and tan A minus B. These are both fractions. Tan A plus B is tan A plus tan B. Divided by 1 minus tan A multiplied by tan B. And then we have tan A minus B. And that's equal to, what would you say, tan A on top, tan A minus tan B. It's following the same pattern. And then on the bottom, different sign, 1 plus tan A tan B. Now you might identify one of those as the angle between two lines. So write all these into your copies. The two cos, A minus B and A plus B. The sines and the tans. And the more you engage with these just by writing them down, the easier it will be not to have any fear when you come to trying to simplify equations or proofs. Now most of these proofs, they're kind of like hide and seek. It's like there's something within the proof that you're going to have to do that you'll have to find hidden within these trigonometric identities, the four different types. Okay, so with double angle formula, what is a double angle? Well, double angle is twice an angle. There's 3 cos, there's 3 sin, and there's 1 tan formula in the formula booklet. Cos 2a is either cos squared a minus sin squared a, or cos 2a is 1 minus tan squared a divided by 1 plus tan squared a. And there's also another formula with cos 2a in it, but it starts with cos squared a. And cos squared a, well, it can be written two ways. It can be written as 1 over 2 times 1 minus cos 2a. Or you could just put 1 minus cos 2a over 2, whatever way you choose. Similarly with sine, there's 3 sine 2a's. Sine 2a is equal to 2 cos a sine a. Sine 2a is also equal to 2 tan a over 1 plus tan squared a. And then similar to the cos squared a, there's a sine squared a with sine 2a inside the bracket. Sine squared a is equal to 1 over 2 times 1 minus cos 2a. So it doesn't have a sine 2a, it's cos 2a, sine squared outside the bracket. So they're the double angle formulas for cos and sine. We also have one double angle formula for tan. Tan 2a is equal to 2 tan a over 1 minus tan squared A. So take these down into your copies. Be aware of them. Don't try and learn them off, but just be aware of how they look and how they can be simplified. And we'll move on to the next part. So we have products to sums and differences, and a product is a multiply. So these look like this: 2 cos A cos B is equal to the cos of A plus B plus the cos of A minus B. We also have 2 sine A cos B. So there's 4 different versions of this. 2 sine A cos B is sine A plus B plus sine A minus B. Then we have 2 sine A sine B which will be cos A minus B minus cos of A plus B. And finally, with the sums and differences from products, we get 2 cos A sine B is equal to sine A plus B minus sine A minus B. Now let's look at the sums and differences to products. So adding and subtraction turning into multiplies. So we have cos A plus cos B, which is going to be equal to 2 times the cos of A plus B over 2, multiplied by the cos of A minus B over 2. We also have the cos of A minus the cos of B. That's equal to minus twice the sine of A plus B over 2 multiplied by the sine of A minus B over 2. Just move up a little bit. We also have sine A plus sine B and sine A minus sine B. So sine A plus sine B is equal to twice the sine of A plus B over 2 by the sine of A minus B. Sorry, not the sine, but a cos. But a cos of A minus B over 2. Twice the sine of A plus B over 2 by the cos of A minus B over 2. Then we have the sine of A minus the sine of B. And that's equal to twice the cos of A plus B over 2 multiplied by the sine of A minus B over 2. So let's have a look at some questions that relate to these. Just checking back over my work here. The cos A minus B is actually a plus sign in the middle. And the cos of A plus B, good to check back over your work, is a minus sign in the middle. So in 2019, we had cos 2 theta show that cos 2 theta is equal to 1 minus sine squared theta. We can rewrite cos 2 theta as cos theta plus theta, which is how I noticed that mistake at the beginning. So that's equal to cos A cos B, or cos theta minus sine theta sine theta. If you remember that from the top, cos A plus B is equal to cos A cos B minus sine A sine B. And because A and B are the same here with theta and theta, we can write it as this. So that's going to give me, on the right hand side, on the left hand side we're going to have cos 2 theta. On the right hand side it's going to be cos squared theta minus sine squared theta. So we can get a value for cos squared theta or sine squared theta. We should be able to, now we can see, let's look back up at what they're looking for in terms of sine. So we want to change cos squared. You guys should know from earlier on in trigonometry, cos squared theta plus sine squared theta is equal to 1. So what's cos squared theta equal to? Cos squared theta is equal to 1 minus sine squared theta. So we can replace cos squared theta with 1 minus sine squared theta. We also have a minus sine squared theta there. So we're going to get cos 2 theta is equal to 1 minus 2 sine squared theta. So what we had here was replacing cos 2 theta with cos theta plus theta, and then identifying that we could replace cos squared theta with 1 minus sine squared theta. So that's one way to do this question. There are a couple of other ways. Let's have a look at those too. So we can kind of do this question in reverse nearly as well. If we look at the right hand side and we say that the right hand side is equal to, okay, well, we know from, again, cos squared theta plus sine squared theta is equal to 1 sine squared. So we have a sine squared here. So sine squared theta is equal to 1 minus cos squared theta. So what happens if we put that in? 1 minus twice this guy, 1 minus cos squared theta. And if we multiply that out, we're going to get 1 minus 2 plus 2 cos squared theta, which is minus 1 plus 2 cos squared theta. Now, cos squared theta plus sine squared theta is equal to 1. We have a 1 here, so this could help us. So minus 1 times cos squared theta plus sine squared theta. What would that be equal to? That would be equal to minus 1 times 1, which is minus 1. So if we bring that over and replace it, we're going to get minus 1 by cos squared theta plus sine squared theta plus 2 cos squared theta. And that's equal to minus cos squared theta minus sine squared theta plus 2 cos squared theta. So the minus, and we've got a minus 1 and a 2. So we've cos squared theta, 1 left, minus sine squared theta. And if we go to our identities, cos squared theta minus sine squared theta, well, we could change it to cos squared theta is cos theta by cos theta. So it's kind of what we started with the last time, minus sine theta. Sine theta, so that's cos A, cos B, minus sine A, sine B, which, let's just double check, that's equal to cos 2, cos A, cos B, minus sine A, sine B, cos A, cos B, all the way up, cos A, cos B, cos A, cos B, minus sine A, sine B is equal to cos A plus B here. So that's going to be equal to, which is equal to cos 2A or cos 2 theta. So another way to solve this question. Okay, could be asked to use the Moivre to show this. Now, the key to using the Moivre to show this is how do we get cos of twice the angle with the Moivre? Well, if we just have cos theta, and the Moivre is the power, so when we have something to be squared in applied maths, that number, that power is going to go in there. So it's going to be cos 2 theta. So we have cos theta plus I sine theta to be squared. That will give me cos 2 theta. So let's have a look how that works. So that will be equal to cos 2 theta plus I sine 2 theta. Now what we need to do is we need to multiply this bracket out. It's going to give me cos squared theta plus twice cos theta by I sine theta plus I squared sine squared theta. So this becomes a minus 1. So the real part of the left hand side is cos squared theta minus sine squared theta, and the imaginary part is plus I times twice cos theta sine theta, which we're not going to need because the imaginary part equates to the imaginary part, and the real part equates to this real part here. So now we can say, and we've seen this already, we can say cos 2 theta is equal to cos squared theta minus sine squared theta. So we know what we're trying to show in sine squared, so we want to get rid of cos squared. So again, cos squared theta plus sine squared theta is equal to 1. So we're replacing cos squared theta, which is 1 minus sine squared theta. So 1 minus sine squared theta minus sine squared theta is 1 minus 2 sine squared theta, and that's equal to your cos 2 theta. So if you're asked to use the Moivre, just try and be aware of how we get to what they're asking us, equating real parts and imaginary parts. Okay, let's try this. And prove tan A plus B is equal to sine A plus B over cos A plus B. So we need the replacement method, so that hide and seek. Let's go find sine A plus B and cos A plus B. So here they are. Oh, I wrote A there earlier. I don't know what I was doing writing A there. That's a B. I hope you all saw that at the beginning. They're shouting, going, what's this crazy person doing? So cos A plus B is cos A cos B minus sine A sine B. And sine A plus B is sine A cos B plus cos A sine B. So let's bring them down below. So I just forgot to write the second part of the proof. Prove tan A plus B is equal to tan A plus tan B over 1 minus tan A tan B, not sine over cos. But we know that tan is sine over cos. I was jumping to the first line of the solution. So tan is sine over cos. It's given in the tables as well. So tan A plus B is sine A plus B over cos A plus B. And from above, we've taken down sine A cos B plus cos A sine B over cos A cos B minus sine A sine B. Now, the key to this proof is this 1 here. How do we get a 1 in this position? We'd have to divide everything by cos A cos B. So let's write that out with dividing everything by cos A cos B. So we're going to get sine A cos B over this guy, cos A cos B. We're dividing everything by cos A cos B. Plus, still on top, cos A sine B divided by cos A cos B. And we're dividing that by, and we're dividing everything on the bottom by the same, so that's just going to become a 1. We can change that to a 1 minus sine A sine B divided by cos A cos B. So let's see what happens here. We have 2 cos B's here, they'll cancel. We have 2 cos A's here, they'll cancel. And we know that sine over cos is equal to tan, so this one here, this sine over cos is going to be tan A, so that's equal to tan A. This sine over cos is going to be equal to tan B. And on the bottom we have 1 minus, this becomes sine over cos, that's tan A. And the one beside it becomes tan B. So that's our proof.